So this is the 52nd session on relative velocity. So in this chapter, in this video, we'll take up the relative velocity numerical problems for case 4. So what is case 4 has been fully discussed in 42nd video. In 42nd video, you'll get all the details of case 4. Okay. So we take up the problems on case 4 for mutually translating frames. Okay. So case 4 problems we'll take up. So case 4 is what I've already specified in 42nd video. That is all other cases other than case 1, 2 and 3 will come in case 4. So in case 4 nothing definite can be said. You have to read the problem and then decide on the at that time which method to apply to solve these problems of case 4. So no general rule can be given. Okay. So I'll take up problems on case 4. Alright. So first question is this. First question is this, what I'm telling. A person running to the right observes raindrops to fall at an angle alpha with the to the left of the downward vertical. To the left of the downward vertical. To the left of the downward what? Vertical. When he doubles his speed, he observes raindrops to fall at an angle beta. Angle beta. At what angle will he observe raindrops to fall if he trebles his speed? One more thing is given. Assume that raindrops fall at some angle to the left of the downward vertical with respect to ground. To the left of downward vertical with respect to ground. Okay. Answer should be in terms of alpha and beta. Alright. So I love this. Okay. Love this also. So, what first we have to do, we have to identify the object under consideration and the frames under consideration. Object under consideration is raindrops, which is denoted by R say. denoted by say R. Instead of M frame we have the man frame denoted by M. Instead of F frame we have ground frame denoted by G. Alright. Now I write down the vector equation. VRG is equal to VRM plus VMG. Okay. Now see, magnitude of VRG is not given. Only one thing is given. It falls at some angle to the left of the downward vertical. That is in this way. This is the downward vertical. Raindrop with respect to ground move in some angle to the left of downward vertical. So we know its magnitude, but some angle which is also not specified. VRM also, velocity of rain with respect to man, nothing is given, but its direction is given for two values of the VMG. And VMG no value is given, but it is given that initially it was some speed and he was observing the raindrops to fall at an angle alpha. When it doubles his speed, he observes raindrops to fall at an angle beta. When it trebles, then what angle will he see? So then nothing is known about magnitude, only angles are known. And this also nothing explicitly has been mentioned. So it is none of the case 1, case 2, case 3, therefore it's problem of case 4. Okay. Now what we've done in such questions, we assume that in first case, let us assume that raindrops are falling. This is a downward vertical. This is a raindrop VRG, which is falling at some angle theta to the left of downward vertical. This is specified in the problem that raindrops are falling at some angle theta to the left of downward vertical. They are falling at some angle theta to the left of what? Downward vertical. So some theta they have not given specified, but I have assumed it. Okay. Now, suppose in first case, person runs at a speed v with respect to ground towards right, as given in the problem. Then he observes raindrops to fall at an angle alpha. From this equation, what we do? We solve this for VRM. So VRM becomes VRG minus what? VMG. This becomes VRG plus minus VMG. Alright. Now let us assume that VRG has a constant magnitude of V say. And suppose initial value of VMG is U. Suppose. Initially the person is running towards right at a speed U say with respect to ground. Okay. So now VRM is what? Vectors of these two. So to draw the arrow for VRM, we draw the vector diagram. VRG is known, some V at angle theta. This is VRG. This is V. That is VRG. Now VMG is U rightward minus VMG is U leftward. This is equal to U minus VMG is U leftward. Vectors of these two is VRM. So with these two as adjacent side, we complete the parallelogram. The diagonal of this parallelogram show common tail of these two vectors. This is VRM. Now this VRM makes an angle of alpha with a downward vertical to the left of it, as shown here. Alright. Now I rub this one, okay. Now see, this is a right angle triangle. If you extend this backward, this is a right angle triangle. This is the hypotenuse VRM. This is VRM sin alpha. This is VRM cos alpha. So from this we see that tan alpha is equal to how much? Tan alpha is equal to this by this. Now this is how much? This side, this is also a right angle triangle. This is V. This is theta. So this becomes how much? V cos theta it becomes. So tan alpha is this by this. So in denominator it comes how much? V cos theta it comes. So tan alpha becomes how much? Here it comes V cos theta. Alright. And this side, this by this is equal to V cos theta. Now this side equal to this side plus this side. Now this is U. This is also U, opposite sides of parallelogram. and this is v, this is theta, this is v sine theta. So this distance is how much? V sine theta, and this distance is how much? U. So this complete distance is u plus v sine theta. So here we write u plus v sine theta. All right, u plus v sine theta. So tan alpha becomes v cancel out, sine by cos becomes tan theta, plus u by v, 1 by cos theta becomes how much? Sec theta. This is the first equation. Now when the person doubles his speed, he observes the raindrops to fall at an angle beta. So now, but when the person runs, only v doesn't change, theta also does not change. Only what changes is what? U becomes 2u and alpha becomes beta. So for second case, instead of alpha we take beta. Tan theta remains tan theta, plus u becomes 2u. 2u by v into kya? Sec theta. Alright, this is the second equation. Now the third condition is, if the person trebles his speed, that is if Vmg becomes 3u, then at what angle will he observe the raindrops to fall? Suppose that he observes the raindrops to fall at an angle say phi. Then tan phi is, as we wrote for tan alpha, tan beta, we'll write for tan phi. So tan phi becomes tan theta plus u becomes 3u. V remains the same. Sec theta also remains the same. Okay. So now we have to find phi. Alright, fine. Now I wrap this one. So now we have to determine this value of phi in terms of alpha and beta. What do we do? We subtract 2 minus 1 and 3 minus 2. So second equation minus first equation becomes what? Second minus 1, tan beta minus tan alpha. Tan beta minus tan alpha. That becomes how much? Tan theta goes away. This minus this becomes what? 2u by v sec theta minus u by v sec theta. This becomes how much? U by v sec theta. Now this is the fourth equation. Now what do? We do third segment, the second equation. Third equation minus second equation implies what? Tan phi minus tan beta. Tan phi minus tan beta. That becomes this minus this. These two goes away. This minus this again becomes u by v sec theta. This is the fifth equation. Now we have to determine the value of what? Tan phi. So from 4 and 5, right side both are same. U by v sec theta, u by v sec theta. So these two also should be same. So from equation 4 and 5, it follows that tan beta minus tan alpha is equal to tan phi minus tan beta. So tan phi becomes 2 tan beta minus what? Tan alpha. This becomes tan phi. So tan phi is 2 tan beta minus tan alpha. Fine. Now I wrap the first column. So from this we get phi in terms of beta and alpha. So phi becomes tan inverse 2 tan beta minus what? Tan alpha. This is therefore the required answer. Alright. So this was the first problem on case 4 in the 52nd session on relative velocity. Fine. I will take up one more problem on case 4 in this video. Second problem. Alright. Next problem I will take up. Now the second problem is this. A straight river flows towards east. At a speed u with respect to ground. S is a steamer. S is a steamer which moves from P1 to P2. Now I have this one. P1 to P2 and then back to P1. And then back to P1 in total time T. P1 and P2 are the opposite two points on the opposite sides of river as shown. P1 and P2 are 2 points on opposite side of the river as shown below. Find the speed of steamer with respect to river, assuming it to be constant, for both upward and downward journey. Okay. And one more thing is given. P1 and P2 are separated by distance L. This I have it, okay. See, if you solve these types of problems now, solving objective questions of mains and advanced becomes much easier. If you solve these such kinds of problems, then you take up problems on relative velocity or any other chapter for mains and advanced, by just seeing it you will solve it. There is no doubt at all. But if you take easy problems, then you will not have confidence and accuracy and speed, okay. But if you solve such types of questions, for example, if you solve one such question of this type, from one single question you can solve at least 15 to 20 objective questions, okay. So you will get much more speed you will gain if you solve problems of this type, alright. And P1 and P2 are separated by distance L. P1 and P2 are separated by a distance L. And P1 P2 makes an angle of alpha with the river flow direction. Alright, at an angle of alpha with the river flow direction. Alright, so this I have it now. So what we do, first of all, I identify the object and frames under consideration. Instead of object, we have the steamer denoted by S say. Instead of M frame, we have the river frame denoted by R say. Instead of F frame, we have the ground frame denoted by G say. Alright. Now I draw the top view of the situation. This is the river, top view of the river. River flowing at a constant speed u with respect to ground towards east. P1 and P2 are 2 points on the opposite banks of the river. This is the line joining P1 P2. This is separated by distance L. And this line P1 P2 makes an angle of alpha with the river flow velocity. Now the steamer moves from P1 to P2 and then back to P1. And total time for the complete journey is capital T. Alright. Now capital T, as I have just now mentioned, is total time for complete journey is T. Now we have to find the value of constant value of speed of steamer with respect to river. Assuming it to be constant for both up and down journey. Alright. So now the question is from where to start the problem. Okay. So now where to start the question, that is the main issue. Okay. Now T is the total time taken by steamer for the complete journey. That is to move from P1 to P2 and then back to P1. So T can be written as T1 plus T2. T1 is the time taken by the steamer to move from P1 to P2. And T2 is the time taken by the steamer to move from P2 to P1. Now we have to know the expression for T1 and T2. T is given, but T1, T2 are not known. This is the starting point of the problem. Okay. Now how to find T1, that is the question. T1 is the time taken by steamer to move from P1 to P2. Now when steamer moves from P1 to P2, it covers a distance of L with respect to ground at a constant speed of say VSG1. So time equal to distance by speed by VSG1. Okay. So T1 becomes L by VSG1. Alright. Now to know T1, we should know VSG1. Now question is how to find the value of VSG1. For that, what we do, we write down the vector equation. What is the vector equation? VSG1 is equal to VSR1 plus VRG. Now see, VRG we have complete information, U in eastward direction. VSR we don't know anything, neither magnitude nor direction, nothing. VSG1 also we only know direction from P1 to P2. But VSR we don't know anything, neither magnitude nor direction. So it is not a problem of case 1, not a problem of case 2, not a problem of case 3. Therefore it is a problem of case 4. So by deciding on the question, you have to decide how to solve the question. Let us assume VSR1 to be V. We don't know V, we have to find out. And VSG1 we only don't know the direction from P1 to P2. VSG1 we only know the direction from where to where, P1 to P2. Alright, fine. So now how to find VSG1? Now what we do, we draw the vector diagram. Now first we draw the arrow of these two vectors with the tails coincident. So this is equal to VRGU. This is equal to VSG1. VSG1. This is alpha. Now we have to draw the arrow for VSR1. Tail of VSR1 coincides with tail of these two vectors. And it lies on the side of VSG1 not containing VRG. That is on this side. So this I will write it here. Okay. So here I write this one as VSR, that is V. Let us assume this angle to be theta. Now we with these two adjacent sides, we complete the parallelogram such that this is the diagonal. And then we slightly adjust the diagram so that diagram is drawn properly. Okay. You can adjust the side lengths. Okay. So that diagram is properly clear. So now what we do, we write down VSG1. So what we write VSG1 as, that becomes U cos alpha plus V cos theta. V cos theta plus U cos alpha. Now to know VSG1 we must know theta. U and alpha are given, but V is not known, theta is not known. V we have to find only. We must know theta also. Now I rub this one. So to know VSG1 we must know theta now. Now resultant of these two is along this direction. So resultant of these two along direction normal to VSG1 is 0. So component of V and U in this direction cancel out. So V sin theta is equal to U sin alpha. V sin theta is equal to U sin of alpha. Alright. So one equation we have obtained here. Fine. So now what we do, we substitute VSG1 here. So T1 becomes how much? T1 becomes L by Vsg1 becomes V cos theta plus U cos alpha. V cos theta plus U cos alpha. So T1 we have obtained. Now what we have to do, we have to find the value of T2. We write down the expression for T2. Now T2 is the time taken by the steamer to move from P2 to P1. In the reverse journey also, the steamer covers the distance of L with respect to ground at a constant speed of say Vsg2. So T2 will be written as what? L by Vsg2. This is T2. Alright. T2 becomes L upon Vsg2. This is T2. Now to know the expression for T2, we must know this and this, but L is already given. We have to know the expression for Vsg2. Now to know the expression for Vsg2, what we should do? We should again write down the vector equation as we did in the first phase of this problem. Okay. So Vsg2 is how much? Vsg2 is equal to Vsr2 plus what? Vrg. Alright. Vsg2 becomes Vsr2 plus what? Vrg. Fine. Alright, clear. Now Vsg2 is equal to Vsr2 plus Vrg. Now this again we have complete information, u along eastward direction. This we don't know the direction, but expression for V is same as specified in the problem initially, but direction we don't know. In fact, V is also not known, but symbol we are using the same V. And Vsg2 we know the direction from P2 to P1. Therefore it's not a case of case 1, case 2, case 3, any of them. It's a problem of case 4. So now to know Vsg2, what we have to do, we draw the vector diagram. We draw the arrow first, we draw the arrow of these two vectors with the tails coinciding. Vrg is in this side, u. Vsg2 is something like this. This is Vsg2. This is alpha angle. By this angle becomes interior angle, pi minus alpha. Now we have to draw the arrow for Vsr2 with its tail coinciding with the tail of these two vectors. And Vsr2 is on the side of Vsg2 not containing this. That is, Vsr2 should be something like this, Okay, let us call this angle as say phi. Alright, fine. Now what I do, with these two adjacent side, we complete the parallelogram. With these two adjacent side, we complete the parallelogram. Now we have completed the parallelogram. Okay. Now this one I rub it. Okay. So now from this equation we see that Vsg2 is how much? Vsg2 is, this is again Vsr2, V cos phi plus U cos pi minus alpha. V cos phi plus U cos pi minus what? Alpha. Vsg2 is equal to V cos phi minus what? U cos alpha. Okay. Now to know Vsg2 we must know phi. Now how to determine phi? Resultant of V and U is along this direction. So resultant of V and U in direction normal to this is 0. So component of V and U in this direction should cancel each other. So we should get V sin phi is equal to U sin pi minus alpha. So V sin phi is just equal to U sin alpha. This becomes sin alpha by trigonometry. See, from these two equations it is observed that theta and phi are same. See, U sin phi, U sin alpha, V sin theta, V sin phi. From this it implies that V sin phi is just equal to V sin theta. That meaning phi is just equal to how much? Theta. So we substitute phi in this equation. So Vsg2 becomes what? Vsg2 becomes V cos theta minus U cos alpha. This is Vsg2. So T2 becomes what? L by Vsg2. So V cos theta minus what? U cos alpha. This becomes T2. Alright. Now I love this first column. Okay. So if you solve such kinds of problems, then you can solve the objective from single question of this type. At least 15-20 objective can be solved. And if you have speed in solving such kinds of problems, solving the objective questions for mains and advanced is much easier. You just see it and write it down in few, say half a minute, 1 minute, that's all. So it is definitely you must try problems of this type. So now we know that total time for the complete journey is what? Total time is equal to T1 plus T2. The T1 we have already determined here. L by V cos theta plus U cos alpha, and T2 becomes L by v cos theta minus what? U cos alpha. Now we simplify it. It becomes 2lv cos theta by v square cos square theta minus u square cos square alpha. This becomes t. Alright. So this is a quadratic in v cos theta. You can see it. Now I'll rub this one. हो गया. This is all right. So for this is a quadratic in v cos theta, you can see it. So this I write this equation in this way: v square cos square theta minus u square cos square alpha is equal to 2lv cos theta by t into what? Cos theta. All right. 2lv by t into what? Cos theta minus u square cos square alpha is 0. Is a quadratic in cos theta. You can see it. U alpha theta, they are all given. U alpha t, they are all given. V and theta are known. Quadratic in v cos theta. We solve this equation quadratic. By quadratic theory, this becomes how much? 12 by t plus, minus cannot be. So it has to be plus. So minus sign is rejected. Into what? Minus b square. So minus 2l by t. 12 by t whole square minus 4ac plus b square minus 4ac minus b plus minus root under b square minus 4ac. So b becomes minus 12 by t. 4ac becomes 4 u square cos square alpha upon what? 2. Now 2 goes away. So v cos theta becomes L by t. And this also 2 goes away. L by t I take common. 1 plus ut cos alpha by L whole square. Okay, fine. So this is the value of v cos theta. And v sin theta is also known. V sin theta is known to be u sin alpha. It is given. So if you square and add, squaring and adding. Squaring and adding, what do we get? Add up this one, okay? So squaring and adding to v square cos square theta plus v square sin square theta, v square common, cos square theta plus sin square theta 1. So squaring and adding, we get v square equal to u sin alpha whole square plus L square by t square 1 plus under root 1 plus ut cos alpha by L whole square into square. So v is equal to root under u sin alpha whole square L square t square 1 plus under root 1 plus ut cos alpha upon L whole square and whole square again. Okay, this is final answer. This was the 52nd video on relative velocity, in which I have taken up questions on case 4. Okay, so next few videos again I will take up problems on case 4, and then chapter on relative velocity will be finished. I think roughly around 3 more videos will be made on this fourth case, and relative velocity chapter will hereby be finished. So there will total in all 55 videos on relative velocity as I specified previously also. So I close it here. Alright, fine.